Okay, so this is a video to try to explain something I do in programming. I mean, many programmers do, but using spreadsheets, which more people understand. So the idea is the same, but hopefully by seeing it in a spreadsheet, you will be able to grasp what's the whole point. So Uh, this is called refactoring. This is what we call it in programming. And I'm gonna do something exactly like that in this spreadsheet. So in this spreadsheet, what I want to do is essentially find out the amount of inflation that happened in a 6-year period, because Uh, those are the presidential terms in Mexico. So this is in order to calculate by president how much inflation each presidential term had. So the problem is that I can find this index, and with the index it's very easy to calculate, but the index only goes far back up, to 2003. The one I could find. Maybe there's another, but I found historic inflation by percentage up to 1970. Now I know how to convert one to the other, but essentially it's the same data, just in a different way. Like, for example, if I divide this index divided by the 2022 by 2021, what I get is minus 1. I get exactly the same number that I found in this other same number in this other resource, but only up to a point. So one way to like, I cannot just sum the these percentages. Let me calculate the percentage of one period, which is from 2013 to 2018. Okay, so it's this one. Okay, I need 2012 as well. So it's essentially dividing this by this. That's the amount of inflation on that 6-year period. But uh, this is not doesn't tell people that much, because it has to be analyzed. So it's 4.18%. So uh, let's say something costed like 10 pesos at this point. Then 1 year later is this times this. Oh, my plus 1. Okay. So it's 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 like that, but okay, it's not very clear from here. But if, for example, I start with something that is this value, like 80 pesos, then at the end is 103.02. So this is correct. This is the same thing as here, but this is variable inflation, and this is like steady inflation of 4.18. But it gives you, I mean, it's essentially the same thing, but just compressed into a single number, and I cannot just sum cannot do a sum of these or an average, because the average of this is what, 4.19. It's close, but it's not the same. And actually, I wonder if I could do the same. Well, whatever. I'm gonna calculate. Let's see if the average works. I don't think so, but anyway, let's do the calculation properly. So I'm gonna start with this 1970 as the base, so that's gonna be 100, and then I calculate by year what will be the index based on that number. So it's this times 1 plus the percentage of inflation, and then just all of those years. Now this number is not very useful, but it serves the same purpose as the actual reported index. If I divide this by this, I get the same percentage that is reported in this other source, right? So these two are equivalent. Okay, so this index is useful, and with this index I can now do the same thing, but for older years, like 1976, it will be this chunk. I mean this 1976 divided by 1970, that will be 229, but annualized it's 1/6, minus 1 is 14.86. Okay, and I can do the same for all the other chunks. That's a lot of inflation right there, but this is cumbersome to do this. Actually, let's see if the average is the same, but I doubt it. No, it's not the same. And as the inflation goes higher, it's different, right? So I cannot just do that operation. Is because this is exponential growth. The average doesn't help. Okay. Now, but this is cumbersome. I can do this in a list, but again, that's not very convenient. Okay, but these ranges can be calculated using the offset function. For example, this one, it will be 1971. This one will be that plus 6, and so on. Oh my god. And then this one will be offset 0. Offset of this minus that locked. Okay. What's the problem? The offset. I will do the offset later. The actual function. So it will be like that. So offset of D2 by that amount. I think that's all I need, right? Maybe 0. Right. Unlock the D2. So this will be the first number. And then the second number is going to be the 8. Okay. So I want this over this. That's going to be the percentage, which I can do directly by just doing this over. It will be the 8 over the 2, right? That's it. So I don't need all this. And then this will have to be analyzed. And then -1. What's the problem? Typo. Okay. So there we go. That's the same thing. Now I don't need this column and I don't need this. Okay. So these are the values that I want. Let's copy the president. Yes. Except the last one. The last one is different calculation. But this is what I want, okay? But so this is what I had. This is a problem solved. But here comes the refactoring. I don't want to have this column here because it's not useful information. It doesn't tell me anything. I'm using this column just to obtain this number, but there should be a way in which I can obtain this number, and there is. Like if I multiply each one of these terms, but 1 plus that, 1 plus the second number times 1 plus the third times 1 plus the fourth plus 1 times fifth times 1 plus the sixth. I made a mistake here. It's times. Okay. And once again, to analyze it. Ooh, it's wrong. Okay. 3, 4, 5, 6, 7, 8. Oh, this is it should be a plus. Okay. So that's the same number. That's how I can obtain the same number, but just using the percentages. I have to multiply each one, which is the same thing that this is doing, except multiplied by 100 and then divided by 100. Like if this starts with 1, it's the same thing, exactly the same thing. Just multiply each one. So, for example, the first one will be yes, essentially this, and then the second one will be these two multiplied, which is 1.11. Let's show more digits. Yeah, it's the same thing as this one. Okay, so this is just another way to represent this in the same thing. Okay, so I could do that, but this is not, this is, again, it's not convenient, this cumbersome to type this formula over and over, and then we'll have to shift it and whatever. So one formula that helps is product. I can just say like multiply all these numbers. The problem is that I need to add 1 to each one of these. Okay, so if I do that here, I'm just say like this is 1 plus this. Now I multiply that range. I mean, this is the same thing, but again, analyze minus 1. Okay, it's the same number. The problem is that this doesn't solve anything, because I still will need another column to add 1 to each one of these. And here's where a trick that many people don't know is very useful, which is array formulas. So I'm going to explain quickly how they can be used in this case. So normally people just use one value per cell, and then each cell has one value. But what you can do is have multiple values in a single cell, like this. So this single cell has 3 values, and then I can do stuff like let's add them all up. So which is the same thing as adding this up, except instead of using 4 cells, which is these 3 plus the formula, it's everything is contained in 1 cell. Now I can do something like give me this range. This doesn't work. What? Oh, until I do Control Shift Enter, which creates this array formula. It may be different in Excel and other software, but it's, you just press Control Shift Enter, and this creates the array formula, which gives a result that is multiple rows in this case. Now, in this formula, I can write the formula, but this is for every. It's not for a single cell. It's for an array of cells. So this is the same thing as this, except the formula is in a single cell. All of these cells don't have anything really. And then I can do something with that result, like adding them up, except I don't need this list. I can just do it directly. Okay, so here, instead of a product of those, I can say a product of array formula 1 plus the range I want to add, and this is exactly the same thing, right? But now I don't need anything else. This just, everything is contained in this cell. So that's it. That's the magic that allows me to get rid of all this complex multiplication. Just do it one product, array formula of that, and then I have to do it in a way that is automatic like this one. So calculate the offset. So I need instead of B3 B8, I need something that calculates this range automatically. Now here what I was doing is offset offset from D8. Let's use the D2 instead. Well, D3. But now instead of 1, I want 6 cells. But you can do it right here from the formula because it has a height parameter. So height 6 with 1, it gives me all these values. No, these values, which is what I want. Well, not the D one, actually, it's the B one. It's that, but not actually those. I want 1 plus that, which doesn't work unless I do array formula and then I get exactly what I want. So this is what I want. Then product that, and once again analyze it, -1. That's it. This calculates the same thing, but now using this year as the offset, and then get the range automatically. So if I use that here, that's it. It's the same, exactly the same number, except let's get rid of this. Except now I don't need this column. I can just do it directly, and that's refactoring. It works exactly. The code, if we can call this code, is exactly the same. I mean, it produces exactly the same result. It's completely different, and it's trading. I mean, this is very complicated, but it's not complex in the sense that it's just one formula. In the and how it was before is that we had many cells in order to spread the same thing that this formula is doing over many cells. So it was more complex because it had more parts. This is a single thing, it's just a formula. And this is what programmers do all the time because this simplifies the code. Now I can do things like saying like, okay, instead of doing by 6 years, I want to do it by 3 years or maybe 12 years or whatever. But I don't need to change a lot of things. I just change one formula and that's it. So yeah, that's an example of refactoring. And other than the raw data, I just need like and the list of years. I just need one formula and that's it. Okay, so I think I'm gonna link the spreadsheet to the video, and I hope you find it useful. That's it.